The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
You can tell by looking around my shop that I love making video game controller mods. So I was excited when the next generation started because it meant I could make all new mods. And that's what we're going to be doing today, making a single-handed controller accessibility mod for the Xbox One. Let's get started. So a little backstory. Around 6 or 7 years ago, I was contacted by someone who lost a limb in the Iraq War. And he came back and he wanted to continue playing video games because, you know, young people like to play video games. And he's like, but I can't now because, you know, controllers require two hands. And it's like, oh yeah, that's a good point. I never thought about that. And his question was, could you make a single-handed controller so I could, you know, continue to play video games? And I'm like, oh, that's a very interesting challenge. Yes, I will give it a shot. And, you know, I did that, and then I put it on the internet. And then, like a lot of other things I've done, I put it on the internet and everyone's like, oh wow, I want that too. So since then, I've made a lot of single-handed controllers. I've made, I had a product that came out called the Axis controller from eDimensional. And I also build them one at a time, specialized for people. Now we have a new generation of consoles, Xbox One and PS4, so it's time for me to make single-handed controllers for those consoles. So there's the Xbox One controller. Take off the battery pack. Looks like this is a panel here. Come on. There we go. Reveal some screws. Come on. My fingernails got instantly weaker in the course of 10 seconds. There we go. Okay, so this gives us access to the screws we need. And there's almost always one under the label. Yep. Yes. Using my handy iFixit bit set. Okay. So there's a few differences. Oh, that's right. This faceplate comes off as well. It's like Darth Vader. What is it? So there's a couple wires here. So Xbox One has rumble motors in the triggers for some reason. And that's what this gray and black wire is here. And these two wires connect the standard rumble motors. I wrote it in my diary so I didn't have to remember. Okay. So there's two circuit boards inside this controller. And the reason for that is so the D-pad can be good. The Xbox 360 controller was a great controller, but he's a nice person, but the Xbox 360 controller was great, but the D-pad was famously bad. And the reason it was bad was because there was a single circuit board inside the controller, so the D-pad was attached to the same level as the analog sticks. But the analog sticks obviously need to be taller because they have, you know, they have an assembly. See? That makes them need to be taller. So in this case, they put the analog sticks on a lower circuit board, so, you know, their height is compensated for. Another thing that's convenient for hacking is because the two PCBs have to connect, that means there's connectors. And then on the side, you can see little surface mount pins. And you can solder directly to those to get all the signals. Very handy. And here's the lower board. It's kind of interesting. They actually have 3 of the face buttons on this board, and then the 4th face button is on this board. So, wow, that's pretty aggressive. There's your bumpers. See, when you push the bumper in, that lever pushes the tech switch. And this is interesting, these metal dome switches, that's pretty much exactly what they had in the old Atari 2600 joystick. So I've discovered in my earlier tests, because of course I've already taken this apart before, this board we don't actually need to remove in order to do these mods. I just wanted to show you inside of it. So I'm going to put this back together. We're going to build a right-handed controller since that's the most common request. The idea is to put all the buttons and controls on the right-hand side. So obviously the D-pad is really hard to reach, so we're going to actually reproduce that with this little multiple direction tack switch. It looks like a tack switch, but it's actually a four-way joystick, and it even has a click in button. And I got this from Element 14. So I'm gonna just make little marks here of where the pins go. There we go. I'm connecting these 6 wires to the switch, and I've flayed the wires in such a way so they will lay as flat as possible. All right, we have the 4-way tack switch in place. The shell should go back on. And I wired it pretty flat, but I'm going to actually Dremel this down just a little bit just to make sure it has enough room. Now, before I put this back in, I'm actually going to remove this trigger assembly. The triggers on the Xbox One controller work differently than the 360. There's actually a magnet which is secured in place with heat shrink tubing, and when you pull the trigger, that magnet gets closer to or farther away from a Hall effect sensor, which is that guy right there. So it's still outputting an analog signal, it's just getting that signal in a different way. Come on. There we go. Okay, so I'm gonna put this back together. Now here's our D-pad wiring. I'm gonna loop that back around through here. There's 4 connections on the D-pad, and then the other side of each connection goes to ground. And these unpopulated diode surface mount spots give you a place to attach the wires. It's actually pretty convenient. Now these wires come in here. So I actually want to wire the closest one first, which is going to be the left connection, which is going to be this wire. I want to do that first because once I wire it, it's going to be somewhat covered up. So I want to start this way and move out this way in my wiring pattern. All right, so now this is up, down, left, right, left bumper. And then I have this 3D printed cap for it. It's important that you can feel the directions without looking at them. So I made like these, almost like these little spikes on the dome. Because at first I tried a dome, but it wasn't obvious which way you were pushing it. So when you're playing the game, you can feel these spikes and you're like, oh, that's up, down, left, right. But we also want to replicate pushing in the left stick, which is usually called L3. So I'm going to add this little switch here. And I think we can put this guy right here. This isn't as straightforward as it was before with the Xbox 360, but we came up with a way that works pretty good. I'm gonna make a mark here, and then I'm gonna drill through both layers. Okay, it's not gonna go through my fingers. So what I'm gonna do with this little guy is I'm going to affix him right here. There we go. I put the leads on first, and then I hot glue it in place. Then I take a toothpick and I lick it, and I use that actually to hold it in place. That way it doesn't move while it's cooling off. And then I lick the toothpick, so when I'm done I can just twist it and pull it out of the hot glue without ripping up the hot glue. All right, so I'm going to attach one side of this switch to ground. There we go. And the other wire I'll leave loose for now because that's actually going to need to attach to the secondary board. When I do attach this wire, I'm going to make sure there's enough slack. It's always good to have plenty of slack so you can take things apart. So I've got to remove this analog stick because you'll only be able to get at one of them. I'm using this desoldering pump I got from Element 14. You heat up the joint with it, and then you push this button to release the vacuum, and it sucks up the solder. Oh, did a great job. Next, we need to rebuild the left trigger and put it over here. So we have to reproduce this using a 3D printer. Now it's time for a tech timeout. Today's Tech Timeout, we're going to talk about Hall effect sensors, which are basically integrated circuits that can detect the presence and proximity of a magnetic field. We found a couple inside of the Xbox One controller used for the analog shoulder triggers. So what I did was I marked the magnet that I found in there so I knew which polarity it was so I could rebuild it the same way I found it. The reason that's important is because where the Hall effect sensor is in relation to the north or south poles of a magnet will give you a different reading. I wanted to make sure that I put it together the way I found it so it would work.
Do-it-yourself dentistry. Not so easy. Accessing order status, history, and invoices at your fingertips on the Newark Element 14 website. So much easier. Discover how we're making doing business easier. Ooh! And creating all new website features.
Here is the surface mount Hall effect sensor. This is easily the hardest part of the whole project. I made this 3D printed part. I need to glue it right there. So basically it's at the same angle that it was before. A professional opera singer, their mouth gets glued shut in the Twilight Zone. All right, so I drilled a hole here. We're gonna put this secondary trigger right here. So on your right hand, you'll have access to both the triggers. So I will just glue this in place and then I will put in the trigger itself. Here's the trigger with the Hall effect sensor in it. I've brought these thin wires out here to a connector. The thin wires we need because we need them to fit easily inside of this and the trigger to still be able to go around it. But we don't want to use those thin wires to go between two boards because if they flex, they could break. So I attach them to this connector here. I'm going to glue this in place and then I'm going to attach the thicker wires to the plug. So there's a slot in this. Okay, here's the existing stick. So the can is all connected to ground. The center button will also be ground. And then here are the potentiometers. Now the center one is going to be your signal. Then this one here should be ground. Oh wait, it's inversed, yes. Okay, so this is ground and this is ground. And then these two will be the reference voltage. They'll be tied together. Okay. But we're actually reversing the wiring on the one that we're doing because the stick is going to be operating in an inverse fashion. So instead of pushing this way to go up, if you think about it on your leg, you actually push the other way to go up because you're moving it in a different reference. All right, put this guy back over here. I'll finish wiring this. Now I'm not going to rewire the center click, pushing in the joystick, because if you're actuating it against your leg, that's actually really hard to do. That's why we put that button here, so it's easier for the person to do. Because you're already having to do everything with one hand, so the easier it is, the better. Okay, so we're gonna take this guy here, and we're gonna attach him to this. Now, I wish there was a scientific thing I could tell you here, but no, I'm just going to eyeball it. Put in a little hot glue, center it. Okay, so we need 4 wires total for this. We need positive voltage, negative voltage, and then horizontal and vertical. So I'm gonna attach one right there. Bring this over here. And see, that was the long wire, so that we attach that one first, and then we attach the shorter wires once we know how long they kind of need to be. There we go. So vertical, ground, horizontal, positive voltage. Now that everything's connected, I'm going to glue it securely. Not only do I want to glue the stick well, but I also want to get this here and make sure that I do that. While that dries or cools, I can show you this cap. I 3D printed a custom cap, and there's a little lip inside of it. See the inner ring? That will prevent it from tilting all the way in one direction. Oh, I just stuck my finger to the hot glue. That wasn't a good idea. I made this really tight fit so it stays on. There we go. All right, let's make sure we have everything the way we need it. Here's our L3 button. It's connected to ground, and then we've got this ready to connect to the next part. Here's our D-pad and our left bumper. So we can put this guy in place. And we've got to press this into the, yeah, there you go. There we go, now it's connected. We have 4 wires coming here. 3 of them we can attach directly here. This kind of applies, this has the rule of flip to it, as I like to call it. Whenever you put a ribbon cable any place, the ribbon cable will always have to flip. It's just kind of like Murphy's Law. Just get one of those in place, there we go. Now we can do the other 3. Ready to seal it up. Cut a notch here for that thing to go through. And this is nice and empty back here, so I don't have to really trim anything. There's plenty of room for the ribbon cables, but I always still fold the ribbon cables flat, assuming there isn't any room, because that's just the way I roll. This rumble motor holder is going away. All right, it's back together. There's a nice little slit here that the cable comes out of. So actually, overall, the look is much cleaner than the other single-handed controllers I've made in the past. And a big reason for that is there's no big gaping hole at the bottom of the controller like there's with the 360. And also, the headphone is really large. Look at this thing you have to plug in. Now that it's put together, I need to check that all the buttons work. So the left analog is being actuated against my leg, so you move the controller in relation to your leg in order for that. So up, down, that's up, that's down, that's left, that's right. So also the D-pad, I'm not looking at it and I can still find it because I can feel the little arrow teeth that I made. So your right bumper goes that way. If I push in the D-pad, that should be left bumper, yep. And then L3 and all the other buttons. All right, looks like it works. The single-handed Xbox One accessibility controller turned out great. It was fun using the 3D printer in order to make custom buttons for it, and I hope these will help people in the future. In our next episode, we're going to be working with the BeagleBone Black. This is the new single-board computer that runs Linux from Texas Instruments. We'll try to do some fun things with it. We'll see you then.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.